a few more examples of being able to convert these polar equations into Cartesian and graphing. So we have q of theta is equal to -8 cos plus 2 sine theta. And so if we use our technology, first of all, just to get an idea of what the graph should look like, then we would say that we would have -8, and I think it was cos and then sine. Yep, -8 cos of theta plus 2 sine theta. And it looks like that we have a circle, all right, but it's not centered about the origin, okay? And the radius might be a little bit difficult for us to ascertain. It kind of looks like it might be 4, and the center might be something like -4, 1, or something like that, just if I'm kind of guessing, or maybe somewhere around there. But let's see how we can go through and analytically figure out what the equation should be. All right, so first thing I'm going to do is I'm going to rewrite this as r equals -8 cos theta plus 2 sine theta. And the trick I'm going to use with this, sometimes we can square both sides, sometimes we multiply, but in this case, what I'm going to do is I'm going to multiply both sides by r. All right? So if I multiply both sides by r, that's going to give me r squared equals -8r cos theta plus 2r sine theta. And the good news now is that we can go ahead and say that r squared is x squared plus y squared. We know that r cos theta is x, and we know that r sine theta is y. So we have -8 -8x and 2y. Right. Now, to put this into the general form, what we're going to do is we're going to use a technique called completing the square, which we've probably seen earlier in this course, but I'm just going to remind everybody of how to do that. So what we're going to do is we're just going to add 8x and we're going to subtract 2y, and we're going to get 8x squared plus 8x, and I'm going to leave a space, plus y squared minus 2y equals 0. And the trick is, what you're going to do is to complete the square, you're going to take half of the middle term and divide it by 2 and then square it. So I'm going to take 8 over 2 and I'm going to square it. And then I'm going to take -2 over 2 and I'm going to square that. All right. And again, that's completing the square for both of these terms. Now, of course, whatever I do to one side, I have to do to the other side. Okay, so on this side, I'm going to add. Now, of course, we know that when we take 8 over 2 and square it, that's 16. Right? And then over here, that's going to be 1. Okay, so what's going to end up happening is that we end up getting x squared plus 8x plus 16 plus y squared minus 2y plus 1 equals 16 plus 1. Okay, so again, whatever you do to one side, you have to do to the other side. And so we factor. And when we factor this is now a perfect square trinomial. So we get x plus 4 squared. This is a perfect square trinomial. So we get y minus 1 squared equals 17. All right. And so finally, what we can do is we can describe this. And we can say that the center of this circle, okay, so this is a circle. Okay, the center is going to be at the point -4, +1, and the radius is the square root of 17. Okay, and if we go back to our technology, so remember we said the center was -4, +1, and the radius was the square root of 17, which is just a little bit bigger than 4. All right, so that makes sense as to why we're we're a little bit more than what the pole is here. Okay, all right, another example of this, we have 1 equals r cotangent of theta, cosine, minus 1 over r cosecant of theta. All right, so this one looks really ugly, but don't get too disparaged by it. So first thing we're going to do is let's clear out the denominator by multiplying by r. So I'm going to multiply the entire equation by r. That's going to be r equals r square cotangent of theta cosine of theta minus cosecant of theta. Okay. Another thing I'm going to do is I'm going to change all of those cotangents and cosecants into sines and cosines to maybe reduce things. All right, so if we do that, then we get r equals r square. We know that cotangent is sine or cosine theta over sine theta. And then we have, and then that's going to be the cosine of theta multiplied by that as well. And then we know that cosecant is going to be 1 over the sine of theta, right? So, and so at this point, what we might wish to do is multiply the entire equation by sine to clear out the denominator. All right, so we're getting close to being finished with this one. So if I multiply all the terms by sine, that's going to cancel out those denominators, and we're going to end up with r sine of theta, which is good, equals r square cos times cos, cos square of theta minus 1. Right? Now, of course, we can rewrite r square cos square as quantity r cos theta square. Okay, so we have r sine theta equals r cos theta square minus 1. And of course, now we can just use our basic identities. We know that r sine theta is y. We know that r cos theta is x, and it's of course squared, and then minus 1. And now we know that this is just going to be a parabola that's going to be shifted down 1 unit. So this is what our graph looks like for this. All right, so those are the rudiments of polar functions and polar equations. Okay, so main topics to remember: make sure that you can convert coordinates. Right, make sure that you can plot coordinates. All right, and then finally, make sure that you can plot equations. Right, and then also convert the equations from polar into Cartesian. All right. So in the next section, what we're going to do is we're going to start taking a look at calculus operations with polar functions. So how do we take derivatives? How do we find areas? How do we do arc lengths? Those sorts of things.